You're welcome to solve this nice exponential equation, which is 20 to the power x plus 20 to the power x plus 20 to the power x divided by 10 to the power x plus 10 to the power x plus 10 to the power x. This is equal to 100. So what is the value of x? Solution from here. In the numerator, we have 20 to the power x is common. So here we factor out 20 to the power x, so that we'll have 20 to the power x. Here is 1 plus 1 plus 1 divided by, in the denominator, 10 to the power x is common. So you'll have 10 to the power x, factor out 10 to the power x, then 1 plus 1 plus 1. This is equal to 100. The next step here, we have 20 to the power x times 1 plus 1 plus 1, this is 3, divided by 10 to the power x multiplied by 3. So 3 and 3 simplifies, so this is equal to 100. The next step from here, we have 20 to the power x divided by 10 to the power x. This is equal to 100. So this is in the form of a to the power n divided by b to the power n, which we can express as a over b raised to the power n. So applying this exponent property, then here we have 20 divided by 10 raised to the power x. This is equal to 100. So this is the same thing as 2 to the power x. This is equal to 100. To solve for the value of x, we introduce logarithm on both sides. So here is log 2 to the power x. This is equal to log 100. So log 2 to the power x, this is in the form of log a to the power n, which we can express as n log a. So applying this power rule property of logarithm, then log 2 to the power x becomes x log 2. This is equal to log 100. So let's divide both sides by log 2 and also here by log 2. So that now x is equal to log 100 divided by log 2. The next step from here, we can express 100 as 25 times 4. So let's substitute this so that x will be equal to log 25 times 4 divided by log 2. So the next step from here, 25 times log 25 times 4, this is in the form of log a times b, which we can express as log a plus log b. So applying this logarithm property, then we'll have that x is equal to log 25 divided by log 2, then plus log 4 divided by log 2. So let's proceed from here. So we have x is equal to log 25 divided by log 2 plus log 4 divided by log 2. We can express 25 as 5 to the power 2, and we can express 4 as 2 to the power 2. So this implies that x is equal to log 5 to the power 2 divided by log 2, then plus log 4, which is log 2 to the power 2 divided by log 2. The next step from here, log 5 to the power 2, this is in the form of log a to the power n, which we can express as n log a. So applying this power rule property, then x is equal to, this is 2 log 5 divided by log 2, then plus log 2 to the power 2 becomes 2 log 2 divided by log 2. So let's simplify here. Log 2 and log 2 simplifies, so that x will be equal to 2 plus 2 log 5 divided by log 2. So you find that log 5 divided by log 2, this is in the form of log a divided by log b, which we can express as log a to base b. So applying this logarithm property, then we'll have x will be equal to 2 plus 2 log 5 to base 2. So essentially 2 plus 2 log 5 divided by log 2. So we find that log 5 divided by log 2, this is in the form of log a divided by log b, which we can express as log a to base b. So applying this property, then now the value of x will be equal to 2 plus 2 log 5 to base 2. So this is the value of x. This is the value of x. So the next step here is to verify that this value of x, let's verify that this value of x actually satisfies. So let's verify that the value of x, which is 2 plus 2 log 5 to base 2, actually satisfies the equation. Now, if you recall here, we end at 20 to power x plus 20 to power x plus 20 to power x divided by 10 to power x plus 10 to power x plus 10 to power x. This should give us a value of 100. And this one, we simplify this further to 20 to power x, actually, which is common here. So this is 1 plus 1 plus 1 divided by 10 to power x, which is here 1 plus 1 plus 1. And this is equal to 100. So this is 20 to power x divided by 10 to power x multiplied by 3 over 3. This is equal to 100. Now, we simplify this further to 2 to power x. This is equal to 100. Let's substitute the value of x here. So we have 2 to power 2 plus 2 log 5 to base 2. This should give us a value of 100. And you find that this is the same thing as 2 to power 2 plus, now this is the power, so we can express this as log 5 squared to base 2. This should give us a value of 100. So 2 to power 2 plus log 5 squared to base 2. This is in the form of a to power n plus m, which we can express as a to power n times a to power m. So now we have that 2 to power 2 plus log 5 squared to base 2. This is in the form of a to power n plus m, which we can express as a to power n times a to power m. Applying this exponent property, then here we have 2 to power 2 times 2 to power log 5 squared to base 2. This is supposed to give us a value of 100. So 2 squared here, this is the same thing as 4. So we have 4 times 2 to power log 5 squared to base 2. This is supposed to give us a value of 100. Now you find that 2 to power log 5 squared to base 2. This is in the form of m to power log a to base m. This is supposed to be equal to a. So this implies that 2 to power log, this is 5 squared to base 2. This should give us a value of 5 squared. And 5 squared in this case, this is equal to 25. So substituting this, we'll have 4 times 25. This is equal to 100. So 25 times 4, this is 100. And it's clear that the left hand side is equal to the right hand side. And that implies that the value of x, which is equal to 2 plus 2 log 5 to base 2, actually satisfies the equation. So kindly follow the steps, like this video, and kindly subscribe. So like this video so that it can be recommended to other viewers. Thank you.